Hi guys, in this video I'm going to be focusing on some Add Maths, specifically differentiation questions, right? So just a reminder for you guys, I do give online maths classes, right? Physics classes and chemistry classes. I will be starting a new Add Maths class in August, right? That's August 2021. Right? So those of you who don't know me as yet, my name is Terry David. And if you want to get in contact with me, you can send me a WhatsApp on this number here, right? I'm a past national scholarship winner in science, right? I also have a degree in electrical and computer engineering, management, and I also have an MBA. And I'm also the author of the official KEEP physics study guides for CXC, right? I'm the sole author of those books, and those books are the recommended books on the CSEC, the KEEP physics syllabus, right? So the first question I'm going to look at in this video, I'm going to look at the June 2012 question. I'm not sure which question it was, but it's 2012, right? And it's a differentiation question. So in this question here, we are asked to differentiate the following expression with respect to x, simplifying your answer. So here's what we have to do here. So the expression is 3x plus 4 over x minus 2. So it's 3x plus 4 it's 3x plus 4, right, over x minus 2. That's what we want to differentiate. Now, if you look at that carefully, that is actually a quotient. So we want to differentiate this. So we're going to put d on dx, right? Now, first thing we're going to do, we have to make a substitution here. So we're going to say let u, right, equal to 3x plus 4. So therefore, du dx, that is the differential of u with respect to x, is going to be equal to 3, right? We also have to let v equal to x minus 2. So therefore, dv dx, you're differentiating v with respect to x, you're going to get 1, right? Now, just remember when we are differentiating something like this, d on dx of, let's say, ax to the power n, right? This is our differentiation rule, right? It's going to be n a to the power nax to the power n minus 1. That's essentially what I'm using here, right? Now, what we've done, we've let u equal to 3x plus 4. We've let v equal to x minus 2. Now, there's a rule, right? There's a rule called the quotient rule. So d on dx, right, of u over v is equal to v du dx, right, minus u dv dx, right? So you all need to know this rule when it comes to a quotient, and then this here is going to be v squared, right? Now, v du dx, all we're going to do here now, so we want to differentiate, this is what the original question is. It is to differentiate 3x plus 4 over x minus 2, right? So we're going to substitute now because we have all the information required to use the formula. We know what v is. V was the bottom or the numerator, the denominator. So this is going to be x minus 2 multiplied by du dx, which is this fella here. That's 3. So you're multiplying that by 3 minus u dv dx. U in this case is 3x plus 4, right? Multiplied by dv dx, which is 1, all over v squared, which is, where is v again? X minus 2. So it's x minus 2 squared, right? Now, in order to simplify the numerator, right, we need to simplify this piece here. So this is going to be 3x minus 6 minus 3x minus 4 all over x minus 2 squared, right? So if we simplify the top, the 3x minus 3x will give me 0. Minus 6 minus 4 is going to give me minus 10. So it's minus 10 over x minus 2 all squared, right? So that's basically my answer for the first part, part A, right? And we're getting 4 marks for this here. So that was pretty straightforward, right? You just need to remember the quotient rule, right? So let me get a blank slide for the other two parts now. Now, in part B now, we have a point P, and they said it lies on this curve. So this part we're doing here. Point P lies on this curve, right? And this is the curve here. Find the equations for part 1. We want to know the equation of the tangent to the curve at P. So what we need to do, the first thing we need to do is to find the gradient of the tangent at the point P. So my curve is y equal 3x squared plus 5x minus 12. So y is equal to 3x squared plus 5x minus 12. That's the 3x squared plus 5x minus 12. Right. So that's the equation of the curve. And the point P is 210. So the point P is 210. Right. That's my point that lies on the curve. Now, the first part of the question wants us to find the tangent to the curve at P. Right. So this part 1 we're working out here. So first thing we need to do, we need to find the gradient of the tangent. So we need to find what is dy dx, right? We need to find the gradient function. So when we differentiate 3x squared, we're going to get 6x, right? When we differentiate 5x, you're going to get 5. So this is my gradient function. I can use that to find the gradient of the tangent. So when x is equal to 2, right? Because that's the x coordinate of the point P, right? I'm going to substitute that into my gradient function. So dy dx, right, is going to be 6 multiplied by 2 plus 5. That is 6 to the 12 plus 5, and that's going to give me 17, right? So therefore, the gradient of the tangent is equal to 17. So therefore, gradient of tangent, right, is equal to 17. So you know the gradient of the tangent, and you know that it passes through the point 2,1, right? So therefore, if we need to work out the equation, so equation of the tangent, right, is given by y is equal to mx plus c, right? This is the general formula for a straight line. So y is equal to, you know what the gradient is? The gradient is 17, so it's 17x plus c. So our objective right now is to find what c is, right? But we have to use this point here in order to figure out what c is. So we know that when x is equal to 2, y has to be equal to 10, right? So we're going to substitute x and y into this equation that we have here in order to figure out c. So therefore, 10 is equal to 17 multiplied by 2 plus c. So therefore, c is going to be equal to 10 minus 17 by 2 is going to give us 34, right? So therefore, c is going to equal to 10 minus 34 is going to give me minus 24. So therefore, the equation of the tangent, right? So the equation that they want is going to be y is equal to 17x minus 24. So that's my equation of my tangent, right? So that's part 1 of the question. We worked out the equation of the tangent. The next thing we want to work out is the equation of the normal to the curve at the point P, right? So you find an equation of the normal. Now, once you have the gradient of the tangent at that point, it's very easy to figure out the gradient of the normal, right? So this is what we know. We know that the gradient of the tangent, right? That's what we worked out in part 1. So the gradient of the tangent, right, is 17. That's what we got in this part here. We worked out this before. We got 17. So if you want to know the gradient of the normal, so therefore, the gradient of my normal right? Now, remember the relationship between a tangent and a normal. If you multiply the two gradients, you should get -1. That's the relationship between a tangent and the normal to a curve. So therefore, if you know what the gradient of the tangent is, all we need to do is to invert the 17, right? So we're going to get 1 over 17, but you need to put a minus sign in front of this, right? So the normal and the tangent, they are perpendicular. And when it comes to perpendicular lines, if we multiply their gradients, we should get -1. So 17 multiplied by -17, we should get -1, right? So you know the gradient of the normal, and you also know what the point P is. Point P is the same point we're talking about, 210. So this here is 210, right? So therefore, the equation of the normal is going to look like this. All right, y is equal to mx plus c, right? But you already know the gradient. M is your gradient. So y is equal to minus 1 over 17 multiplied by x plus c. So now we're going to use this point P in order to figure out what that c is, right? So what we're going to say is when x is equal to 2, right? Y is equal to 10. That's what we know. So therefore, 10 is equal to minus 1 over 17 multiplied by 2, right? Plus c, right? So therefore, we can rearrange this and we can say that c is equal to 10 plus 2 over 17, right? So therefore, c is equal to, let's work that out, 10 plus 2 over 17, right? And what we're going to get here is 172 over 17, right? So therefore, my equation of my normal, right, is going to be y is equal to minus 1 over 17x plus 172 over 17, right? So that's my answer there for the second part, right? That is the equation of the normal. And the last part now, they said the length of the side of a square is increasing at a rate of 4 centimeters per second, right? Find the rate of increase of the area when the length of the side is 5 centimeters, right? So this is connected rate of change. That's what we're doing here. So just to recall, right? If we have a square, because it's a square we're talking about here, right? This, in a square, all the sides are the same. So the area of the square is actually equal to x squared, right? So that's the area of the square. Let's see what else they said here. They said the length of the side of the square is increasing at 4 centimeters per second. So if they're talking about the length of the side, they're talking about dx dt, right? And that is increasing at a rate of 4 centimeters per second. So this is 4 centimeters per second, right? Because it's length that is increasing, so it's dx dt. That's what we know. As well, they said find the rate of increase of the area. So what the question wants us to find is dA dt. They want the rate of increase of the area. And they said when the length is equal to 5 centimeters. So what they want us to find, they want us to find dA dt, right? The rate of increase of the area. We do know what this is. And we know what x is. They said x is equal to 5 centimeters, right? So x is equal to 5 centimeters. So when you have a question like this, this is what you need to do. You want to find dA dt. That's what you want to find. So dA dt could be found by multiplying dA dx, right? Multiplied by dx dt, right? That's how we're going to find dA dt. This is what I want us to find. Now, a is equal to x squared. So from that expression, I can find what dA dx is. dA dx, if I differentiate 2x, I'm going to get, sorry, if I differentiate x squared, I'm going to get 2x, right? So this here is going to be 2x, right? Multiplied by dx dt. You know what that was? That's 4. So that is 4 to the 8x, right? But we have another piece of information here. They told us to find the rate of increase of the area when x is equal to 5. So therefore, what you're going to say now is when x is equal to 5, right, comma, the dA dt, which is what the question asks us for, is equal to 8 multiplied by 5, right, which is equal to 40, right? Now this is the rate of increase of area, right? So this is going to be centimeters squared s to the minus 1, right? So centimeters squared s to the minus 1, right? So that's my answer for this particular question, all right? So this is June 2012. So let's look at the next one here. This is June 2013. So we have, make sure I have enough space here to do this question. All right, so we want to differentiate this equation they've given us here, right? Y is equal to x cubed minus 3x squared plus 2, right? All right, so what I'm gonna do, let's y equal x cubed minus 3x squared plus 2. Y is equal to x cubed minus 3x squared plus 2. X cubed minus 3x squared plus 2. Minus 3x squared plus 2, right? And part 1, they want to find the coordinates of the stationary points of y. Now, when you want to find stationary points, right? For stationary points, your dy dx has to be equal to 0, right? So whenever you hear that, that's the first thing that should be going through your head. Dy dx is equal to 0 at a stationary point. Now, a stationary point could be a maximum point, a minimum point, or a point of inflection, right? Now, we have the equation here, so we can find dy dx. So therefore, dy dx is equal to, when you differentiate x cubed, you're going to get 3x squared, right? When you differentiate 3x squared, you're going to get, this is going to be 3 2's 6. So this is 6x, right? And when you differentiate 2, you're going to get 0, right? So we've just differentiated that here now. Now, at a stationary point, so you can see that, at a stationary point, right? Dy dx is equal to 0. That's what we know. So what we're going to do, we're going to put what we have for dy dx, which is 3x squared minus 6x is equal to 0. And what we're going to do now, we're going to try to solve for x. That will give us the x coordinates of the stationary point on the curve. Stationary points in this case, right? So we're going to factorize this. So we can pull out 3x, and this is going to be x minus 2 is equal to 0. Right? So now we can say either, you're going to get two solutions here. So either 3x is equal to 0, therefore x is equal to 0. So this here is one solution for x, right? So a stationary point occurs here. Or I can get another solution, which is x minus 2 is equal to 0, and therefore x is equal to 2. So that's my second stationary point, right? Now, what the question asks for? They ask for the coordinates of the stationary point. So what we've done, we've just found the x value. So what we need to do, we need to find the y values. So when x is equal to 0, y is going to be equal to 0 cubed minus 3 multiplied by 0 squared plus 2, right? And when we work this out, 0 cubed is 0, and then 3 by 0 squared, that's 0. So therefore, this is going to be 2. So therefore, 1 point, right, is going to be 0, 2. That is one stationary point. Next thing we need to do, we need to use this value here, x equal to 2, to find the other stationary point. So when x is equal to 2, right, y is equal to 2 cubed minus 3 multiplied by 2 squared plus 2. So 2 cubed is going to give me 8. 2 2's are 4, 3's are 12. So this is minus 12 plus 2, right? 8 minus 12 is minus 4, and minus 4 plus 2 is going to give me minus 2. So therefore, this second point here is going to be 2 minus 2, right? That's going to be 2 minus 2, right? So it's 2 minus 2 and 0, 2. All right, so the next part of the question now. So that is part 1. So again, 5 marks for this. The next one we want you to work out is the second derivative of y. So you want to find the second derivative of y. Whenever they ask you for the second derivative, what they mean is d2y dx squared. Now don't get too confused with this. All they're really asking you to do is to differentiate a second time, right? So the expression you have for dy dx, you're going to differentiate it again. And they said, hence determine the nature of each of the stationary points, right? So we can use d2y dx squared in order to determine if a point is a maximum, if it's a minimum, or if it's a point of inflection, right? Really and truly, we can determine if it's an inflection easily from d2y dx squared though. So let's see. What do we have for dy dx? 3x squared minus 6x. So we have dy dx is equal to 3x squared minus 6x, right? So what we need to do, we need to find d2y dx squared, right? So you're going to differentiate a second time. So 3x squared, when you differentiate that, you're going to get 6x. And when you differentiate 6x, you're going to get minus 6 in this case here. So this is my second derivative, d2y dx squared. Now what we need to do, we need to take the values of x, right? Remember we got two values here. We got x equal to 0 and x equal to 2. So for x equal to 0, we're going to take that and we're going to substitute it into d2y dx squared. So this is going to be, so d2y dx squared is going to be 6 multiplied by 0 minus 6, right? 6 by 0 is 0. So 0 minus 6 is going to give me minus 6. Now, when you get a negative value for d2y dx squared, right, this is going to be a maximum point, right? So this here is a maximum point, right? So that point that we found, which was 0, 2. So 0, 2 is a maximum point, right? 0, 2 is a maximum point, right? And what we're going to do now, we're going to substitute x equal to 2 into that same expression. So d2y dx squared, right, is going to be 6 multiplied by 2 minus 6. And that's going to give me 6 to the 12 minus 6, which is going to give me 6. So whenever d2y dx squared is positive, right, that's a minimum point. So you all need to learn that off, right? So this is a minimum point, and that point actually was, how much it was? It is 2 minus 2. That's what that point was, 2 minus 2, right? So 2 minus 2. So that's what we've done here. We've worked out the nature of the points. When they say nature, they want to know if it's a maximum or a minimum. So this is what you generally need to remember. So when d2y dx squared, right, if it is less than 0, meaning it's negative, right, that means it's a maximum point. That's what that means. It means it's a maximum point. If d2y dx squared, right, is greater than 0, that means it's positive, right? That corresponds to a minimum point, right? So that's the solution for the part 2 of this question here, where we had to determine the nature. When they say nature, they mean maximum or minimum. Next thing we want to differentiate. We want to differentiate this here, right? So y is equal to 5x plus 3 cubed multiplied by sine x, and they want you to simplify your result. So here's what we're going to do. 5x plus 3 cubed. So y is equal to 5x plus 3 cubed multiplied by sine x, right? Now, you have to be able to look at expressions and determine what method of differentiation we're going to use here. So if I were to just look at this, I can clearly see that I'm going to have to use the product rule in this case here, where this is one term and this is another term, right? So that is, let me make sure I have it correct here, 5x plus 3 cubed sine, right? So what we're going to do, we're going to have to make a substitution, just like we in the question previously, we did the quotient rule. This one here is the product rule. So we're going to call that U and we're going to call that V, right? And when it comes to, so this is what the product rule is. If we have U multiplied by V, we can say that dy dx, right, is equal to U dv dx plus V du dx, right? That's our product rule, and we need to learn the product rule, right? So what we're going to do, we're going to say let U equal to 5x plus 3 cubed, right? So that's the first thing we're going to do. On the other hand, we're going to say let V equal to sine x. right? So from that, we can get dv dx already. dv dx is just, when you differentiate sine x, you're going to get cos x. So this is going to be cos x, right? Now we need to differentiate this here. Now you can just use a formula. There's a formula we can use to just differentiate this, by the way, right? So du dx, right? You can work this out directly. What the answer is going to be, it's going to be, we're going to have to take the 3, right? And multiply by, you know what? Let me just do it another way. Use the chain rule here to show you what to do, right? I'll use the chain rule. I don't want to just give you an answer and you're trying to figure out what I did there. So I'm going to differentiate this here, right? But what I'm going to do, I'm going to make a next substitution. Let's say t equal to 5x plus 3, right? So therefore, let's go in the corner here. Therefore, u is equal to t cubed, right? Now, if t is equal to 5x plus 3, right? That means that dt dx is equal to 5, right? Because when you differentiate 5x, you're going to get 5. Now, u is equal to t cubed. So therefore, du dt is equal to 3t squared, right? So now I'm going to use this information here and this information here to work out the differential of this. That's what I'm going to do. So du dx, right, which is what you're trying to find originally, is equal to du dt, right, multiplied by dt dx, right? So du dt is 3t squared. So this is 3t squared multiplied by 5. So this is 15t squared. But remember, you knew what t was. You had substituted a value for t here. So therefore, t, in this case, that was here, right? That's 5x plus 3. 5x plus 3 squared, right? So this is basically, we're using a chain rule here in order to work this out. So what I've done, I've worked out du dx, right? So now let's see what's happening here. So let's write back what we're trying to work out. So we want to work out 5x plus 3 cube, right? Multiplied by sine x. That's what we're trying to work out. Now we're going to use the product rule here. So dy dx, right? Now the product rule is u dv dx, right, plus v du dx. So now all we're doing here, we're going to substitute because we have all the information required to answer the question. So u, where is u? U is 5x plus 3 cube multiplied by dv dx, right? So where is dv dx is here. It's cos x. So multiply by cos x plus v, where is v? V is sine x, so it's sine x, right? Multiplied by du dx, which is this down here, right? So that's 15, open brackets, 5, one second. There's 5x plus 3 squared. So this is 5x plus 3 squared. So let's just neaten up this answer a little bit, right? So what I'm going to do, I'm going to, can't do anything with this. 5x plus 3 cube cos x plus, let's put the 15 in front. So 15, right? And I can put the 5x plus 3 squared sine x, right? All right, so that is that the last part of the question? Oh yeah, that's part B, right? So basically what we've done, we've used the product rule in order to work this problem, all right? All right, guys, so we've done the 2012 and the 2013 paper, right? So look out for more videos on solutions, right? All right, guys, so take care.